Hello, I'm David. We can't have enough Davids in the room. So I'm from the University of Glasgow, and for this year, my project was concerned with building applications on the SAFE network. It's quite a broad title, as you can probably appreciate, but one of the main things that we wanted to do is really build the groundwork for possible future work at the university. I don't want to say too much on that in case I get into trouble, but in the next few years, there could be more work because my project was quite successful in my opinion. But this, what you're about to see here, is just a small video that I prepared for the university. It's quite basic in its explanations, but hopefully for the benefit of anyone watching online or anyone new to the project, it could actually be quite useful. So this video is actually meant for the marker at the university, so they could watch and understand more about the SAFE network and see the project working. So after the video is done, I'll come back up and go into some of the more technical details and answer any questions you've got. Thank you. The title of my project was Building Applications in the SAFE Network. The SAFE Network is a decentralized data storage and communications network that provides a secure, efficient and low-cost infrastructure for everyone. The SAFE Network brings with it an entirely new way to build applications, in that for the first time ever really, there's been a decentralized data storage platform where users ultimately own and control their own data. This is juxtaposed to a system like BitTorrent, which is also a data storage platform, but users don't really own their own data. So in BitTorrent, what happens is when you upload a file, it gets split into these small chunks. These small chunks are then seeked from other peers in what is known as a swarm. So you join the swarm and you say, hey, I want this chunk of data, that chunk of data, and the other node in the swarm will serve those chunks to you if they have them. The SAFE network is kind of similar in that data is broken down into 1 megabyte chunks before it's uploaded to the network. And these chunks of data are stored in what are called vaults. Now, vaults join together to form what is known as a section. A section is a group of vaults that are responsible for looking after a certain address range. So in the SAFE network, addresses are based on 256 bit addresses. So a given section is responsible for a certain portion of that. For instance, if there is 2 sections, one would be responsible for all addresses that start with 0, and the other section would be responsible for all addresses that start with 1. I'm talking binary here. What this means is that through different mechanisms, you can securely store data on the SAFE network for either private consumption or public consumption. So my application specifically looked at the public consumption of data. And to do that, what I did was create an application called SafeWiki that could facilitate the storage and browsing of ZIM files on the SAFE network. Now, a ZIM file is simply a file format that allows you to store content that comes from the web. The most popular usage of a ZIM file is to store websites like Wikipedia. So with the creation of my application called SafeWiki, it's possible to store archives of a website like Wikipedia on the SAFE network and then serve it to everyone. So I'll just show you how that works now. Here I've got 4 vaults running. So these vaults, as you can see, have started to already talk to each other and they are ready to serve data. So what we'll do is we'll open up the SAFE browser. So the SAFE browser is kind of your entry point to the SAFE network, and it's what allows you to log in to retrieve your data and also just to authenticate yourself to the network. So I'm just going to create just a fake account here. You see we're just registering here. If we go back over here, you'll see that one of the vaults is now managing a client account. So you can just see that we're now storing data. So I'll just allow that, and that's us now. So now we're actually authenticated with the SAFE network and we're ready to work. So what we'll do is we'll come over to SafeWiki and I'll show you how this works. So SafeWiki itself is actually based on an application called KiwiX. Now, KiwiX is a long-standing project that is dedicated to bringing educational content to the world. So whether this be you're in the middle of the Atlantic Ocean or in North Korea, with the use of these ZIM files, they are offline archives of websites like Wikipedia, so you can access these great resources without needing an internet connection. SafeWiki exploits this to use the safe network for the storage of these files. So let me just connect to the safe network. So you'll see waiting on safe network. Come over here, we'll click allow. So this is just authenticated the application to work with the safe network. So you can see we're now connected to the safe network. I'm now going to create what is known as a ZIM folder. Now, a ZIM folder is just a collection of these ZIM files, so it allows people to more easily find the location of them. So let me just create a ZIM folder. So now I've created a ZIM folder called Stack Overflow. So what I'm now going to do is upload a coffee ZIM file to the network. So this is literally an offline archive of the coffee Stack Overflow pages. So I'll just click upload, and you can see in the right hand side here, the file has now been uploaded to the network. Okay, so I just made a little cut there while the file was uploading. If we go into the vaults now, you can see all of the requests and activity that the vaults have been going through as that file was put onto the network. So what we'll do now is we will go and log out of Ceph Authenticator and create an account. So this, I'm just doing this just so you can see that other users will be able to access the files that another user uploads to the network. Oops, daisy. There you go. Secure password, as you can see. So registering on the Safe network, and there you go. So this is now an entirely new account on the Safe network. So you'll notice that SafeWiki isn't here. So if we come back over to SafeWiki and go into Safe network, and you go connect to Safe network, and there we go, we're authenticated. The one thing you will notice is that this SafeWiki instance doesn't have a ZIM folder. So remember on the old one that we created a Stack Overflow ZIM folder, well, this account doesn't actually have a ZIM folder. So this is a representative of just an entirely new user logging onto the network and wanting to access that ZIM file. So let's just type in the credentials here. So you'll notice the name we use for the collection is the name of the ZIM folder, so in this case Stack Overflow, and the file name, coffee, was the name of the ZIM file that we uploaded. So on the right hand side of the page here you can see all of the reads that are happening from the network. The first time that a page loads in, the first time you open a ZIM file, it actually is a little slower than subsequent page loads. This is because the very first time you open up a ZIM file, we cache the CSS and jQuery and things like that, so that subsequent reads from the network don't take as long. So as you can see, this is the Coffee Stack Exchange here. So I can go and click on a page like this, and it will load in. Up the top here, there's a dynamic search. So for instance, if this was a Wikipedia, you could just go in and type, and search Wikipedia as you would normally, and it would come up and you can browse through. So you can see here that the page popped in quite quick, and you can already scroll through it and look at content. The one thing you'll notice is there's network activity still happening, and it's because the images are still loading in. So there you go. So the benefits of hosting ZIM files in a safe network might not be apparent to begin with, but the safe network is permissionless in that you don't need permission from anyone to upload a file, and that once you upload a file, nobody can alter that file. So by hosting resources like Wikipedia on the safe network, you create this censorship-resistant quality to that data. So if anyone can access the safe network, they can access all of it. There's no way for a government, for example, to curate access to those resources. So in the case of Wikipedia, it's really important for people all around the world to have an uncensored access to educational content, and that's what SafeWiki brings. The whole reason we built this project was to analyse building applications in the Safe network, and it was through building this application that we were then able to evaluate how good the Safe network is for building applications.
Expand upon that a little bit. One of the things you will notice that it was Stack Overflow we were looking at. That's primarily because it's tiny. Like that coffee file was only 50 megabytes there. And basically for the purpose of the video, I didn't want to spend 5-10 hours uploading like the 75 gigabyte Wikipedia to the Safe network, but it does in fact work. I think when I came to the office I showed you Wiki Voyage, was it working? So when I came to do this project, I found it quite difficult to try and think, what did I want to build? But one of the things in the past that caught my eye was the efforts of IPFS to decentralize Wikipedia. Looking at that, when I first saw it, however many years ago that was, I was like, wow, that's quite cool. That's a cool use of that technology. Preaching to the choir here, probably, but I don't think it's possible to overemphasize how important it is that people have access to educational content, especially in other parts of the world where they don't. For example, Turkey have blocked Wikipedia recently, and I could talk about hundreds of examples around the world where the freedom, just the basic educational content, has been restricted to people. So the efforts of IPFS really interested me here. So when I got picked to do this topic, I thought, that's quite a cool idea. So I looked into how IPFS actually did it, and it turns out they took these ZIM files, unpackaged them like into the raw HTML, CSS, blah blah blah, and then uploaded them to the IPFS, which is quite a cool approach. But I thought, why can't I just take it one step further and actually just let KiwiX work as it would normally? So as I said in the video, KiwiX is a long-standing project. I think it was 2007 it was founded in, and they've done all sorts of clients. So for example, there's a C++ one, and what SafeWiki is based on is a JavaScript version. So normally what you see there would actually live in your browser. So you download KiwiX.js as a browser plugin, and then from that you could then browse ZIM files that are hosted on your just local file machine. So again, as I said, Middle Atlantic Ocean, things like that. So I thought, why can't we make that an Electron application? So that was one of the first things I did, and the people behind KiwiX were actually quite excited because that was one of the things they had in their roadmap to do. And it was very simple actually. I'm quite pleased with how easy Electron is to use. And then after I had that working, it was then just a process of basically trying to understand how the Safe network worked. I was actually, before August of last year, I'd never heard of Made Safe or the Safe network before. I'd probably seen it on maybe CoinMarketCap before, the icon flooding past me all the time, but I've never actually looked into it. So I was starting with as a complete novice, so I had to sort of look through the forums and chat to a lot of great people who know who you are, and that helped a lot. And then by January of this year, I started to have like file uploading working and file reading working. What's cool about this is how little I actually need to touch KiwiX. Like a lot of what you see here is actually just powered by KiwiX, and the only thing I really do is intercept like the reads from the local file system and pass this onto the Safe network, and it just works beautifully. It really wasn't that complicated. The most difficult bit really was just understanding how to make that bit work. But as it stands now, this is in its current form, but hopefully later on in the year, I'm going to change this slightly. So at the minute, it's an Electron application, a standalone application that facilitates both the reading and writing from the network, which is cool for this purpose, but for usability, perhaps not. So one of the things I'm going to be looking at hopefully later in the year, if I have the time, is to actually get this just to run client-side JS and pass it, so you just be able to visit our website, safe:/SafeWiki, and you'd have just a website. It would pop up just like this, and you could be able to just type in like your ZIM folder and your target ZIM file and just be able to read it like that, and then hopefully just build a simple application that allows you to upload the ZIM files to the network, so that the average user doesn't need to worry about that, because really for something like this to work, it has to be as simple as possible. Like, it cannot be even remotely complicated, and it can't use any complicated terminology, which is why I hide some of the techniques that I use behind things like collection name. So I'm guessing that a lot of you have worked out how things work in the background. That a Zim folder is actually just a mutable data structure that I emulate through NFS. And then Zim files are simply just placed within that Zim folder, within that mutable data structure, using NFS and just as they're given file names. Part of the reason to do this was it's simple, and secondly, with the hope that possibly in the future other developers might develop applications that can do simple manipulations using NFS, so that perhaps even I didn't need to implement any sort of file uploading or file management capabilities into KiwiX, and it could just be there to facilitate the reading and consumption of that data. Now, an exciting thing is when I talked to the developers behind KiwiX, they were actually quite excited about this. So hopefully, if things keep going with this, we could possibly have some involvement for them with ultimate dream also of getting this merged back into KiwiX.js. But that's a bit of a pipe dream, but we'll see if we can get there. Any questions?